Okay, lesson 76. Out of the 3 lessons for this week, this is definitely the longest one. But it's kind of the most important and the most foundational of the 3 lessons, so please watch the video. I boil it down a lot from the book so that it's easier to understand, so hopefully you'll get this. There's actually 4 parts, I'm only doing 3 of them, combining 2 of them. Functions of negative x, functions of the other angle, trigonometric, I forgot a letter, identities, and rules of the game. So this is fun. These identities, I think you're all going to enjoy those a lot. So you just need to stick with me from the beginning for these things. Alright, let's talk about functions. We've had talked about even functions and odd functions before. Even functions are functions when you put in a negative number, you still get the same thing out. Even functions are symmetric about the y-axis, like a parabola. So let's look at a parabola here. Y equals x squared. You can tell it's even because it has an even exponent, first of all. And then, if I would put a negative number in here, like say I'd put a -2 in for x, and I'd square it, I would get the same thing as if I put a +2 in and squared it. So that's how you can tell it's an even or odd function. If you put a negative number in, you should get the same thing out as if you put a positive number in. So in odd functions, the opposite. When you put an negative number in, you get a negative number out. Odd functions are symmetric about the origin. And this is an example of an odd function, y equals x cubed. If we would put a -2 in for x cubed, we would get out a -8. If we put a +2 in for the x and cube it, we would get out a +8. So you're going, instead of getting a positive out, you're getting a negative out, so it's an odd function. So here's an example. We have y equals -x cubed. If we cube it, we get -x cubed, which shows this right here. Now we're going to relate that to trig functions. Let's start with our sine function. Is it odd or even? So let's try substitute a number in for theta. Let's substitute -30 degrees. So if this is 30 degrees, we know if we're going to put +30 degrees in, if we put sine of +30 degrees, we know we get 1/2, right? So if we do -30, we're going to get -1/2. Opposite over, whoops, this is hypotenuse, this is the square root of 3. So we're going to get out a -1/2. So a sine function is an odd function. You would get out sine of -theta. And so the sine function is an odd function. Keep that in mind. And you can see it's symmetric about the origin. If I put 90 in, we get 1 out. If I put -90 in, we get -1 out. So a sine function is an odd function. Let's look at the cosine function. Even by looking at the graph, you should be able to figure this one out. Look how it's symmetric about the origin. Mine are not too great, but you get the point. So if I put in a -30 for my degree here for theta, normally I would get the square root of 3 over 2 if I had a +30. And -30 would give us adjacent square root of 3 over 2. So we're putting in a negative, we're getting a positive out, so this is an even function. So this would be the cosine of theta, and this would be an even function. And you can see by the graph that it's symmetric about the origin, and so it's going to be even. And then finally the tangent function. We haven't learned how to graph these yet, but we know if we did the tangent of 30, we would get its opposite over adjacent, so we would have got 1 over the square root of 3. If we put -30, we get -1 over the square root of 3. So this one is coming out negative, so it's an odd function. So that's it for even and odd functions. Let's go down and talk about functions of the other angle. This is a lot of information in this lesson. I'm going really fast, so try to stick with me here. Okay, we have a triangle. If this is theta and this is 90 degrees, then obviously this is 90 minus theta would be the degree of this angle right here. So if I had the cosine of theta, cosine is adjacent over hypotenuse, I would get b over c. The cosine of theta is equal to the sine of the other angle, is equal to the sine of the other angle. So cosine would be b over c. The sine of 90 minus theta would also be b over c. The sine of theta is a over c. The cosine of the other angle would be a over c. So they're equal. So the sine of this angle is equal to the cosine of this angle. Same with tangent. The tangent of this angle would be a over b. The cotangent of this angle would be a over b. Remember, cotangent would be adjacent over opposite. So it's a flip version of tangent is opposite over adjacent. The secant would be, secant of theta would be hypotenuse over adjacent. The cosecant would be equal. The cosecant of this angle would be equal to hypotenuse over adjacent. And finally, the cosecant of this angle would be hypotenuse over adjacent. Remember, this goes with sine, and this goes with cosine. Alright, so you just have to keep in mind that these two are equal. This is for when we're going to do trig identities in just a minute, and these are some of the relationships that you have to memorize to do these trig identities. Alright, let's jump into trig identities. Hold on a second. Okay. Now, trig identities are trigonometric versions of proofs. So if you like proofs in geometry, then these will be fun. If you didn't like proofs in geometry, these will still be fun because they're a lot easier. Just like proofs in geometry, you can do them a couple different ways depending on which theorems you use. Doing trigonometric proofs, they also can be done several different ways. So what we're going to do is we're going to prove that two trig expressions are equal. So like example 1, we're going to prove that tangent of x over secant of x equals sine of x. These are the rules of the game here. You can substitute equivalent expressions for any part. Like we know tangent is equal to sine of x over cosine of x, we can substitute it in. We can multiply the top and bottom by any non-zero quantity, and we can combine terms with equal denominators. The only one we're going to do today is this one right here. We're going to substitute. As we get more and more into the year, we're going to start using these other two rules. So let's try our first problem, first proof. You always start on one side, simplify the most complicated side, and try to make it look like the simple side. So here we go. We can substitute, before we get going here, these are some identities that you need to memorize. Tangent of x is equal to sine of x over cosine of x. Just like tangent is equal to opposite over adjacent, opposite would be sine, adjacent would be cosine. Tangent is opposite sine of x over cosine of x. Cotangent is the same as 1 over tangent of x. Cosecant x is the same as 1 over sine of x. Secant of x is equal to 1 over cosine of x. And cotangent of x is just the flip version of this one. So, with those in mind, we're going to try these problems. I think you're going to like them. So, tangent of x, we're trying to get this side to have a sine in it, so when we're picking one of these, right now we only have one to pick from. So I'm going to substitute tangent of x is equal to sine of x over cosine of x. We don't want secant in our answer, so I'm going to look at secant. I can see that secant is equal to 1 over cosine of x. So all I did was rule 1 here is substitute equivalent expressions for any given part. Then we can just flip the bottom. I didn't save myself enough room for this. I can flip the bottom. Cosine of x over 1 times cosine of x over 1. The cosines cross out, and look what we get. Sine of x equals sine of x. And that's all there is to doing these trigonometric proofs. Okay, let's try another one. Cosine of negative theta sine of 90 minus theta equals cosine squared of theta. So we're going to work on this side only and try to get it to look like this side. And if you recall, these, whatever they're called, we did those on the other screen that I had. We can substitute, if we remember what they are, we can substitute these in. So cosine of negative theta. Well, we know if this is an even function, right? So cosine of negative theta is equal to cosine of theta. Remember how even functions, these are the same? And then sine of 90 minus theta is the same thing as the cosine of theta. You can see how it's coming together. Let me just go back and show you these, if I can find them. Hold on one second. Whoops, I drew a line instead of moving my box. Okay, remember these? Sine of negative theta equals negative sine of theta. And we have cosine of negative theta equals cosine of theta. And then all of these. Cosine of theta equals sine of 90 minus theta, etc. So you need to put these in your mind and memorize them. Let's try one more proof. Oops, I didn't finish this one yet. So finally we have cosine theta times cosine theta is cosine squared theta equals cosine squared theta, and we proved it. So that's all there is to proving. You complete one side and it has to equal the other side. Let's try this one. Sine of theta equals cotangent x equals 1 over secant x. So we want to get rid, we want to just have this be 1 over secant x. So the sign I'm going to leave the same. And for cotangent x, we're going to use this one up here. Cotangent x equals cosine x over sine x. Okay, and the sine x will cross out. So now we have cosine x, and we know that cosine x is the same as 1 over secant x. And we got it. So what you might want to do is take all the different identities that I wrote down, like these red ones right here, I'd write those down maybe on an index card, start writing these down, those down, and along with the ones over here, these right here. You might want to have them when you're first starting to have all the relationships written down, because we're going to get a lot more of these. These are like our theorems and postulates that you have to know in order to do these proofs. So that's it for whatever lesson we're on here. What was that? Lesson 76.